Got this one's computer. Your test 1 is not this coming Wednesday. Your test 1 is next Wednesday, which is the 9th. Okay, just want to tell you that. So it's not this coming Wednesday, it's next Wednesday, and it will cover chapter 2.6, 2.7, which is and then the whole chapter 3, 3.1 till 3.4. We will do 3.4 today. And then on Wednesday, we'll do 4.1 and 4.2. Okay, yes, we'll be covering all those. In your test is on Wednesday, so it's not this coming it's not coming this Wednesday, the following Wednesday. I think I hand out the review for test 1 on last Wednesday. If you need to get a copy of your review of test 1 because you're not in class on last Wednesday due to the Zoom. Oh, by the way, this is an in-class test. Okay, your test is all in class, it's not via Zoom. Okay, so you all have to come to class on that next Wednesday for the test. Usually we will spend the first 40-50 minutes to review for the test, and then the last hour and a half, 40 minutes, we will do your test. Your test is around 11-12 questions long. It's not a lot, but some of the questions have, majority of the questions have A, B, C, D on it. So make sure you know that it's although it's only like 10 or 11 or 12 questions, but some of them have like up to G, A to G. So you have to do quite a lot of work on that one. So the review of the test, if you come to my class on this coming Wednesday, which is the February 2nd, you will get a copy of it if you do come. Otherwise, if you don't have a copy of it, go to D2L and get a copy of it. Where in D2L is, you go, I'll show it to you. So it is right on the, you also get an announcement on the test, so you know when it's a test. You go under materials and content, and you go under review, and that is a review test 1A. So it looks something like this. So this is the review of the test, and again, if you look at it, it's 9 questions, but yes, your test is around that 9, 10, 11 questions. But you can tell majority of them has A, B, C, D parts of it. Some students ask me that is the test is like this where you have no room to write? The answer is no. Your test will be look like your notes where you will have more room, plenty room to write. This is not considered a lot. So usually you will get more rooms to write. So your test will look something like this where you got more rooms to write. So I would like to share like this because you will have. The reason why I put it in this form is because it is, I try to save paper to narrow it down to 2 pages. So please get a copy of this if you have not if you didn't get it. Otherwise, come to class on Wednesday, you will get a paper copy of it. Okay. So that is the announcement for your test here, your first test. And again, your first test, you are allowed to use 1 front page of notes. So I would recommend you to start writing something on print or type. So only 1 front page of notes allowed. I don't care how big, how small, type or write or whatever you want to do. And also the next thing is make sure you are only allowed to use a scientific calculator. So please, no cell phone calculators and no graphic calculators. Go buy one. It's not that expensive. It's like $15. Otherwise, you can borrow one from me during the test time. I do have one, but I do recommend you guys to really get one. Just for this class. Anyone have any questions for this test ones? Your online homework 3.2 and 3.3. This online homework is due on this coming Wednesday, so make sure you guys work on it. Okay, so there are 2 sections due on this coming Wednesday. And 3.2, there are 1 question, which is question number 30, which is about the box, the open box. We'll go through this together in class today. The rest of the homework, which is 3.4, which is we're gonna go over today, and 4.1 and 4.2, This homework usually is due on Wednesday because your test is next the 29th. So this online homework is actually due on Tuesday, the 8th, the 8th, the February 8th. Okay. So so make sure you guys know this. Usually if a test falls on a Wednesday, then your homework will be due on the day before that. So I want you guys to do your homework. So work for it. If you can, like today 3.4, work ahead of time. So today's work here is doing question 30 on your online homework. So 3.2, which is this question. Okay, so this is where some students really ask me or have some trouble with it. So this question actually looks something like this. You have a box, and this box for my question is measured 36 inches on the side. So they measure 36 inches here. And what happened is they will cut square pieces on the corner here. So they will take a square pieces off here, and they will take X out on each corner. Okay. And then if you fold on this dotted green line, you will get yourself what we call as an open box. Okay, you will get something like this. And the open box, pardon my drawing, it's not as nice as the picture draw. The open box that you get here will have a length of X. So this X, the height of X, this X is the X that you cut out from this box. Okay. So since you cut out from this box both on X side, so actually the length that you left is gonna be 36 minus 2X. Because the whole thing is 36 and you cut 2X out, the two square X here. So that's why it will be 36 minus 2X. So this means that the length of this is also 36 minus 2X. Because when you fold it, it will become the length here. Now the width of the box, which is this one, is also 36 minus 2X, because you have the whole thing is 36 and you take X out on both sides. So so this width in this case is 36 minus 2X. So this will be also 36 minus 2X. So this is what happens to the box if you take X out. The formula is you want to find, question A is you have to find the volume. Volume of a box is length times width times height. This is the volume of the box. So length is 36 minus 2X. Width is also 36 minus 2X, so you can make it square. And the height is X, the height of the box. So the volume in this case is given us by this formula. So this is your answer for question number 30A. Your volume is 36 minus 2X squared times X, or you can move the X up front here if you want to, it doesn't matter. So this is your answer for question 30A. For question 30B, they ask you for the domain of the box of this function V. So as you know that this is talking about the length. So in order for you to find the domain of it, it all depends on your X, which is your domain. So since these two are the same, so you just need to solve for X here. Okay. Now, if these two are not the same, then you pick the smallest one. The reason why you pick the smallest between, because this is a square, so they are the same, 36, 36. Let's say this is a rectangle, 36 and 24. Then we probably will concentrate on the 24 minus 2X. And the reason why we use a smaller one in this case is because when we talk about the domain, as you know, X in this case is the box that you can cut. So we always concentrate on the smaller piece, because if you only have 24 by 36, the domain here is actually bounded by this 24 because if you cut more than the 24 here, you will find out that you will not work in this case. Otherwise, you will have issues. 36 is bigger than 24, so we don't care about the domain here. Since the length here is the same, so you just solve for x. So x in this case is 18. So is it 18? Yeah, 18. So your domain in this case will be anything that is smaller than 18 because your x here is your box that you cut out. So if you cut exactly 18, you will end up not getting a box because you will cut down the whole square. So if you cut 18 and 18, you will end up have no box at all because you cut off the whole square here. So you have to cut a bit less than 18, for example, 17.9. So if you cut 17.9 on each side of the box here on 4 corners, you will get a very tiny little open box. So that's the reason why your domain in this case is 18. And since this is talking about length, you cannot have a negative length and you cannot have 0. So that means your domain in this case will go from 0 to 18. Okay, so so that is the domain for this box. Part C will be easy. You just need to substitute x as 1. So plug x as 1 over here, and you will get your v. And then you continue plug in x is 2, 3, 4, all the way till 7. And you will get your V answer. Okay, so again, make sure you put this in your calculator. I will change that, Ariel. I will change it. Yeah, I will change your homework set. So that is your question C here is you plug in there and find your V. And then after that, you have to use the table here to estimate the range of dimension, which is within the maximum volume. So in order for us to find the max, so you just look at your volume here, and then you figure out which of the x value give you the maximum. So I do not know because I think it's going to be between 3 and 5 because of the graph that you will see. But again, you will see that your graph will look your Vx value will start from small, and then at one point it will grow to a max, and then at one point then it will taper down to low. Okay, so the maximum is somewhere in the middle of this. So I was thinking about 3 and 5, and then you need to use a graphing utility to graph this graph V. So in this case, if you don't have a graphing calculator, then I will recommend you to use the decimal graphing since it's free. So what you do here is you just type down the volume equations in this case, which is given us by this x times 36 minus x. So you just put this into your function here, into your graph. So x times 36 minus 2x squared. So you look something like this. You can tell by zooming it out by your homework, since your homework is up, see 1,000 here. See that this is up to 1,000. So we're gonna zoom up to 1,000 here. It's not even 1,000 yet. So you look something like this. Maybe I'll just change the. So you find out that your y-axis, if you look at this, is between 0 to 4,000. Your x-axis is between 0 and 12. So we just do it. Your y-axis in this case is between 0 to 4,000. And your x-axis is between 0 to 12. So you will get a better, so you just click on this little tool here that is to change your display. So this is your answer will looks like. I just zoom out a little bit so you can see. So that graph, if you compare it with your answer, let's see what it looks like. Again, you just need to compare it. I think you guys know how to compare your graphs here. That one looks like which one? So it is. You can tell that it doesn't touch the ground at 12, so it's more either these two. And if you look at the highest peak go around 33,000 ish. So I think your answer is this one, because this one only peak up to around 2,000 ish. So I think your answer is that one. And then use the graph. Oops, sorry. And then you have to use this graph to figure out what is the maximum. So if you look at this graph, the maximum is somewhere 6. Okay, so it's somewhere 6. So around 6. So this is around here. And the result in part C. So in part C, you say the maximum is between, oops, sorry, I got it wrong. 5 should be 5 and 7. So that's the reason why that it is 6. So that's why the answer in this case does agree. So again, I didn't fill up these boxes. That's the reason why that I didn't see where is the max. So actually it will go up around 5 and then it tapered down around 7. So that is why the max value should be around 5 and 7, and it's around 6. Okay, so this is your answer in this case. So anyone have any questions on this question 30? This is some of you asked me that. Okay. So make sure you use the Desmos graph to help you with your the question here. Okay, because it will help you, because they ask you to use a graphing utilities, means Desmos. Anyone have any questions for me beside question 30? Otherwise, we start the class today. Save this as your homework. All right, so today we will concentrate on 3.4. That is one big section here. So the whole today's class, 2.5 hours is all 3.4. And this is a very big topic. And I will skip some of the topics here. I will cover the most important topics. And make sure you guys know how to perform syntactic division that I taught you on last Wednesday class. If you do not know how to do syntactic division, either you really pay attention today or practice when you go home. Okay, this is very, very important here. So 3.4 in this case is asking for a 0 of a polynomials. So you have to watch out carefully what kind of zeros they're asking for. So this is something that before even we start doing 3.4, we have a lot of zeros. So again, 0 stands for solutions or x-intercept or factor. Okay, so 1 is called the list of all the possible rational zeros. Okay, so we got a few things that you need to watch out. So don't say zeros and you'd be like, oh, that it is. Then they also want you, they also have the word find rational zeros. So make sure you guys know the difference between listing and finding. Okay. They also want you to find real zeros. So watch out for all these words, and they all means different. And the last one is they want you to find all zeros. So these are all about zeros, so watch carefully. Okay. So if the question is asking you to list, not to find, to list all the possible rational zero, okay, possible rational zeros, this is where you will use P over Q, plus minus. Okay. We have a theorem. We call that as your rational zero test. Okay, you will learn this in today's class. So make sure you read the question really carefully. So when they ask you for a list all the possible rational zeros, you have to use the rational zero test, which we will use P over Q, and that will give you that. And your answer has plus and minuses. Your answer in this case is plus minuses. So what does you guys remember? What is the meaning of the word rational? Like the word rational functions that we used last time. Rational means that it's a number. If we talk about rational number is a number that can be written in a fraction form. P over Q. Can someone tell me a number that can be written down as a fraction form? Like fraction, 1/2, right? Negative 3/4. These are all considered rational numbers. A whole numbers like 1, 2, 3, 4, 0, and negative number like -3. Decimals that is repeating 0.33333, and decimals that is terminating. So these are what we call as rational numbers. So if the question is asking us to find the rational zeros, your answer has to be in the fraction form PQ. That means that if your answer is in the irrational forms like square root, pi, complex I, this answer will be rejected. Okay, so make sure you guys know that when the question is asking for rational zeros, means the answer has to be like this, like a fraction form or whole numbers or decimals that's repeat, decimals that's terminating. Anything that is irrational like pi or square root or imaginary complex number, that is no good. Okay, so that is called finding rational zeros. What is the meaning when I say find real zeros? Find real zeros means your answer has to be rational and irrational. So that means if your zeros came out to be a fraction form like P over Q, like one of these numbers is considered real numbers, and square roots and pi, this is all considered real numbers. However, if your answer came up to be I form, which is a complex form, then you cannot take form of it. And don't forget to make it I in this case is a square of -1. So that means that when you take a square root, if you have a negative inside a square root, that's complex. So that is the one that we do not need for this case. Okay. However, the last one is if the question is asking us to give all real zeros means everything, all of them. That means can be real, can be imaginary, can be anything, everything. So that means your answer can be in the fraction form, in a square root form, in pi form, in I form. So it means it's everything. It's a big trash can, everything goes in there. So make sure you guys read the question really carefully when you do your 3.4 homework, and also when you do my test 3.4. Example here is if you look at your homework 3.4, you will see it. So you guys can take a look at it and then you can figure out what I'm trying to show you. So when you look at 3.4 homework, so like this question is not determined. Use the rational zero test to list the possible rational zeros. Means your answer in this case is number 1. Means you have to use the plus minus P over Q. So if you give me anything that's like number 2 or number 3 or number 4, you get it wrong. Okay. This question wants you to give me the rational zeros of a function. Means you have to give me the second one, means you have to give it to me in the P over Q form. So if your answer is the square root of pi or I or plus minus like this, they will not accept anything. Okay, so make sure you read the question, what kind of zeros they ask you to find. Okay, mostly they are all rational zeros, so that's why it's this way. And then if you look at number 14, they want you to find the real zeros or the real solution. Then your answer will very similar to number 3. That means rational and irrational numbers, irrational solutions will work well here. Okay, and then this one back to rational. Oh, this one is list. Again, class, list means number 1. Okay, and then all real zeros is number 3. So this question is asking A to do number 1 first, and then after that you do number 3. Okay. So these are the stuff that I want to point out to you guys, so you guys know what it means when they ask you for to list and to find all real zeros. Okay, again, mostly what we did here so far is real, number 3. Okay, and then later on you will find yourself doing all zeros. So all zeros means we'll go down to number 4, means anything goes, including imaginary I form. So so that's why when you have the all zeros came out, you find out a lot of things as I's pop up, the imaginary. So that's the reason why that what I want to point out to you here is this: read the question really carefully, what kind of zeros it wants you to do. A lot of students get annoyed or agitated because they didn't know the difference between the list the possible rational zeros, find or determine the rational zeros, find the real zeros, and find all zeros. So these are all the stuff that you need to be careful about. Anyone have any questions with this one before we continue with 3.4?
I had a question about the plus and minus. So do you have to put the plus and minus symbol?
Your online homework does not like, your web assignment does not like plus and minus symbols. Means if you have a plus minus 2, then your answer will be 2 and negative 2. So this is what you have to write down. So all your online homework, all your web assignment homework, they don't like plus and minus. So do not use the plus and minus symbols that you see in your in here. Sometimes when you click on it on the here, that is a plus and minus symbol. Please don't use the, there's a one somewhere here, right? Please don't use the plus minus symbol here because your online homework doesn't like plus and minus symbol. So you have to write your answer twice. But in my test, sure, because I'm a human, I can read it. The reason why they don't like plus and minuses because those are not human. Your computer is created by computer, so that's why please don't use plus and minus symbols in your online homework. More questions? All right, so we're going to talk about some theorem here. So 2.4 is full with theorems. So one is called a fundamental theorem of algebra. What is this fundamental theorem of algebra says? It says that if you have a n polynomial, a polynomial with a degree of n, and in this case is number like 1, 2, 3, 4, 5, then you will have at least 1 0 in the complex number. To be more precise with this fundamental theorem algebra, if you have a degree of n, you should have n complex zeros. Okay, so what does that mean here is if you have a power 4, you should have 4 zeros. These zeros can be complex, and the word complex means it can be fraction PQs, it can be whole number 1, 2, 3, 4, 5, it can be square root, it can be I form, so it can be anything. So so it depends on your power, on your degree. So if you have 4 degree, I'm expecting you to give me 4 zeros. Then it depends on what kind of zeros the question wants. So if a question wants all the zeros, then if this is a power 4, you should give me 4 zeros. But if it's a real zeros, then you have to figure out are the zeros rational or irrational. If they came out to be imaginary, you have to exclude that in your answer. So this is all depends on what kind of zeros we have. But in the fundamental theorem, algebra says it depends on your power. So if you have 4 power 4, I expect 4 complex 0. Complex means it can be I, can be whole number, can whatever it is. Make sure you have 4 of them. Okay. So we're going to talk about the most important theorem in this case. It's called the factorized rational zero theorem. So then I will teach you what is the complete linear factorization here. What is a rational zero theorem? Now, if you look back on 3.3 that I teach you last time, I give you the zeros or the factors here, right? I give you the zeros, I give you the factors here. So it's very easy for us to show that this X or this is a factor is you perform syntactic division on it and your remainder is going to be 0, right? So, so that is easy enough because they provide the 0. So in 3.4, the dilemma you get here in the section 3.4 is they do not give you the zeros or the solutions or the factors in the question. Okay, so you can tell that when you look at 3.4 homework, they don't give you any clue what is the factors or zeros in this case. So, so for students like you guys, you're gonna do syntactic division for any number 1, 2, 3, 4, 5, negative 1, 2, 3, 5, 1/2, 3/4, whatever you have, until you perform it until your remainder is 0. So you're kind of like finding needles in a needle in a haystack because you try to do this. I don't know how many times synthetic division. I can tell you that people when during tests, students erase my test until you get a hole in there because they've been trying so many times and to try to get a 0 in the remainder. So so what we should do, because there's so many numbers you can try, right? Because it's like a jigsaw puzzle. You try to, it's too difficult, to play with it. So so we begin to have some theorem, and one of the theorem is for rational zero theorems. This is only happens when you got the polynomials where your coefficient, the number in front of your x, must be integer, means you cannot have a fractions or a square root or it must be -1, -2, 1, 2, 3, 4, 5, and so this rational zero theorem says that you can take the form of PQ, where P in this case is the factor of the constant term of A0, and Q is the factor terms of the leading coefficient, which is your AN here. Okay, so what you do is you give me all the possible factors. So what times what give you that numbers, and you begin to divide this up, and you do all the total combinations you can have. And then these rational zeros require you to do a plus minuses. Okay, so that means your answer will comes in pair, plus and minuses in this case. So this is called the rational zero theorem. Very important. So I will show it to you here. So rational zero theorem is where you do P over Q, plus and minuses, where P in this case is the factor of the constant term, A0. I just use constant so you guys know. Constant means the term has no an x on it, no x on it. And Qn in this case is the factors, I'm gonna put plurals because it can be more than one, of the leading coefficient. Okay, and when you divide this, you're gonna give me all the division. When you divide this, you have to give me all the possible combination. Okay. And then you need, don't forget the plus and minuses on every single combination. Okay. So I'll give you an example here. So like this example that we have here, question number 9 here. It's given us that f of x in this case is 8 plus 24. Again, what I'm concentrating here is not, I mean, everything is important. So 8 is important. That is for the Q. And 24 is important. That is for the P. And I do not care if the 8 or 24 is plus or negative. I don't care if they are pluses or negative, because when you divide, we have a plus minus, which will take care of all the combinations we can have. So can someone tell me what is the factor of 24? That means what times what is 24? Eight and 3, I put 3. I just arranged it to be nicely. 3 and 8. What else besides 3 and 8? There's a lot of combinations to get 24 besides 3 and 8. What times what is 24?
6 and 4.
6 and 4. So I'm going to arrange this nicely so you guys can see it. So 6 and 4. What else?
12 and 2.
So 12 and 2. And
1 and 24.
and 24. So these are all the factors of 24. Okay. And Q in this case is all the factor of 8, which is a leading coefficient, which will be 1 times 8. And what? 2 times 4. Okay. So these are all the combinations of 8. So in order for us to use the rational zero theorem, you have to give me all the possible combinations of this. So what do I do in this case is I will divide everything, the top here, by 1. So all these there by 1, you will get 1, 2, 3, 4, 5, 5, 6, 8, 12, and 24, because you divide this by 1. Okay, and now you take all this divided by 2. So we got 1/2. 2 over 2 is 1. So we already got 1. So we do not need to rewrite it. 3/2. 4 over 2 is 2. We have that. 6 over 2 is 3. We have that. 8 over 2 is 4. We have that. 12 over 2 is 6. We also have that. And 24 over 2 is 12, which is also we have that. So we found out that 4 over 2, 6 over 2, 8 over 2, 12 over 2, and 24 over 2 is a repeat of what we have. So we're done with 2. So the only thing that we don't have when you divide by 2 is 1/2 and 3/2. And next, we will divide this by a 4th. So we got 1/4. 2 over 4 is 1/2. We have 1/2. 3/4. 4 over 4 is 1. So 1 is already here. 6 over 4 is 3 over 2. 3 over 2, we got it. 8 over 4 is 2. 12 over 4 is 3. And 24 over 4 is 6. So that means the 4 in this case is only 1/4, 3/4. And then the last one we're going to do is over 8. So we got 1/8. 2/8 is 1/4. We already got that. 3/8. We don't have 3/8. 4/8 is 1/2. We have 1/2. 6 over 8 is what? 6 over 8 is 4 over 1/2. 6 over 8 divided by 2 is 3 over 4, right? 6 over 8 is 3 over 4. We have that. 8 over 8 is 1. We have that. What is 12 over 8? Anyone? 12 over 8? Might need to put that down. What's 12 over 8 is? Is 12 over 8 3/2? Right? 12 over 8 is 3/2, which we already have that, so we do not need that. And then 24 over 8 is what? The 3. So we have that. So in this case, this is all the possible these are the possible zeros. So don't forget to give plus and minuses to this. Okay. And this is what if a question asking you to list all the possible rational zeros for this function. And class, how do you list this? Like here, oh my God, you're gonna double everything. 1, negative 1, 2, negative 2. So you have to do this crazy a lot of time. And you have to separate this in common. This is how you enter this in your homework if you have this. And this is called list the possible rational zero for this case. So you got quite a lot to enter here. And if you forget to put a comma in to separate your possible zeros here, your online homework will mark you wrong. And that's where you guys will get frustrated. And that's where you come and talk to me. Okay. And yes, can someone tell me what are the zeros on number 9 that we did last Wednesday? Anyone have my notes here? Can someone tell me what are the zeros here? Hello?
I got, where is it? Oh, it's negative 3/4, 1/2.
Oh, wait, negative 3/4 is the first one, right?
Yeah.
And that is right here. Yep.
And
What
then 1/2.
1/2 right here.
-2.
2, -2. Again, plus minuses take care of it.
And 4.
And 4. So you can find that this number that I forgot who said that. This is what we call as rational zeros. Okay. This is called the list. This is called the find the rational zeros. The one that sorry, can you tell me who are you again? That say that?
Netta.
Neda, sorry. Thank you, Neda. Neda say that. So those are when I ask you to find the rational zeros, those are the numbers that you give to me. But if I call you to list all the possible rational zeros, you're gonna give me this whole entire thing. Okay, so you guys know the difference here. And yes, the number that Neda just mentioned, they are all here. Okay, so that is the power of rational zeros test. Okay, so very, very important. This theorem is actually one of the most important theorem in this section. Without this theorem, you're gonna try to do synthetic division. So what happened here is you try to do synthetic division on one of those zeros that I point out. So try 1. If 1 does not work out, try -1, because don't forget, this can be 1 and -1. And then you try 2 and then -2, and you find out that -2 actually works here. Okay, and that's how we do this kind of work. So that's the reason why people, although it's not a lot of questions in your test, guess what? You're gonna do a lot of crazy synthetic division here. So with that, we're gonna do question 1. This question is asking us to find the rational zero, use the rational zero test to find the rational zeros. So first we have to do the rational zero test. That means PQs. So can someone tell me by looking at question 1, what is the P and what is the Q? P is the last number, 12. And again, I don't care the sign. Don't give me negative, just give me 12. And Q is the leading coefficient. Can someone tell me what is the Q in this case? It will be 1. So if you get 1, you should be happy because you know the factor for 1, right? So can someone tell me what is the factor for 12? What times what is 12? One, 2, 3, 4, followed by what?
6.
And
12.
yep, so these are all the factors of 12. Okay. And the factor for 1 is easy. What times what is 1? 1. So you just need to divide this. So using the rational zero test, don't forget the plus minus, this is important. And you just need to divide this by 1. So 1 divided by 1 is 1. 2 divided, so anything divided by 1, you get back the same thing. So you get 1, 2, 3, 4, 6, and 12. Don't forget, you have plus and minuses. So this, again, when you enter in your online homework, it should be, say, list all the possible rational zeros, and your answer will be 1, plus minus 1, plus minus 2, plus minus 3, plus minus 4, 6, and 12. Okay, so this is not too bad to enter into your homework because it's definitely less than the one that you just did. Okay, so this is called using the rational zero test. Now we have to find the rational zeros. So how do you find the rational zero in question 1 is you have to, if you are lucky, you pick 1 and your remainder is going to be 0. So you have to pick one of this possible rational zero. They are possible. And then you do syntactic division on the function here. So 1, -9, 20, and -12. And hopefully you pick 1 and this fellow will came up 0. If you didn't get 0, you have to try again. So now I'm going to assign you guys to perform some syntactic division for me because I am a bit lazy today. So Ariel, you're going to try syntactic division with just +1. Fossil, you're going to try with -1. So you try it with 1. Hunter, you're going to try with 2. Liz, you're going to try with -2. Neda, sorry, I'm going to use short form here. 3. Fong, -3. Sabrina, you're going to do 4. Sean, you're going to do -4. Zik, you're going to do 6 because we don't have 5 here. And I'm going to do -6. So we're going to break you guys into do your own syntactic division. So go ahead, class. Do your own here. And our main goal here is your remainder 0 or not? Yes or no? I'm going to do -6. Make sure you have a calculator. Where's my cup? Where's my cell phone? And guess what? This is what you have to do in my test. And this is not group work. This is individual work. So for me, -6, no. Because the remainder is not 0. Again, our goal is to get remainder is 0. And usually I would suggest you to try the smaller number first. Don't even go like big number like 6 and 12 or fractions. So I would recommend you to try this like 1, 2, 3, 4. All right, you guys done? Okay. Zik told me 6 work. 6 work, Zik? Okay, I do not know. So Zik says 6 work.
Yeah, it worked.
Hunter, no work, because as long as your remainder is not 0, does not work. 3, give me a remainder, so that is net. Okay, class, give me a second. Let me go through this list together. So I'm reading that. Sabrina say 4 does not work. Okay, Ariel, have you done yours yet? Does it work? Does not work. Okay. How about Fossil with wait a second. Let me go through the list. So how about -1? Does that work?
No.
Okay. List -2, she said does not work. How about Fong -3?
Ned.
Net is 3, right? So I'm talking about you do 3 or -3 net? I'm asking you to do 3. I'm not asking. You're doing 3 here, not -3. Sean here.
Why is it being
It doesn't work.
-4 doesn't work. Nat, you try 3 or -3? Someone is wrong here, I can tell. You must be good in syntactic division. All right, looks like 6 is working, so we're gonna try 6 here. And we'll see. I can tell who will not. After that, I can show you who did not get the correct one. So drop the 1. So 1 times 6 is 6. So this will give me -3, right? 6 times -3 is -18. This will give me 2. Oh yeah, 12 works. That's 12. 6 works, right? Zig, because you get 0. So 6 works. So now you need to find, so we know 6 works in this case. So 6 is a rational 0, but we know this is a power 3. So how many zeros do you need to have if it's a power 3? You should have 3 zeros. So you only found 1. So the other 2 has to be found in your quotient. Remember your quotient? So you will get x squared minus 3x plus 2. This is your quotient here. And in order for you to find these zeros, you either need to factor it or use quadratic formula. So it looks like factoring works here. So anyone? So what's the factor here? What's the factor here?
Is it just x minus 2 and x minus 1?
So what is x in this case?
2 and 1.
So actually, your answer here to find your rational zeros, what is your rational zeros in this case? 1, 2, and what? And 6. So guess what? Ariel, you did wrong. This worked. Hunter, you also did wrong. This works. Try again. Yep. So looks like Ariel and Hunter needs to practice your syntactic. So yes, if you syntactic this with 1 or 2, it should work. Yeah. So this is how we do this kind of questions. And again, class, as I mentioned earlier on the first day of class, you need, first day, on Wednesday, you have to perform syntactic division crazy in this section. And if you haven't done anything syntactic division yet, time to do it again. Questions with this? Okay, so please, I will ask Ariel and Hunter again since they got it wrong. So yes, actually these 2 works. Okay, no, class, in your test, don't mind that here because in your test, it's not my fault. Your bad, you lose points. So don't mind bad here and your bad. So I do want, yeah, 2, yeah. Class, make sure you have a calculator with you. So drop the 1. Hunter, you do it then. What'd you get? Oh, my bad, 2, right? Don't forget, it's a -9. Please, class, this is serious here in your. Oh, yes, it's mostly like this. No, this is the main theorem. The rational zero theorem is the main theorem. And then there are some, but this is the main one. And then there are another one. But if you doesn't know this, forget about the other ones. Okay. Next, repeat. I want you guys to look at question 2. I think you guys have my notes, right? I want you to use the rational zero test to do PQs here now on your own. Do PQs. And the worst case for this question 2 is this is power 4. Power 3 is not bad because when you do power 3, if you found 1 zeros, you can factor or use quadratic formula next because it'll be power 2. But when you have a power 4, things gonna get a little bit tough because we know there are 4 zeros. So you actually have to perform syntactic division twice here. So not just lucky ones, you're gonna get lucky twice. Well, we'll talk about that now. So first, do the PQs first. Again, this is called the rational zero test. All right. So it takes time for this section. That's why I need to assign your test is not a lot of questions. Because look at the amount of work that you're gonna do here. What is P in this case, anyone? What number represent P?
24.
And what number represent Q?
9.
9. And guess what happens if you switch these two numbers around? Everything under that is all wrong. Did we do 24 before? Can someone tell me what is a factor for 24? I think we did it before, right?
Yeah, I got 1, 2, 3, 4, 6, 8, 12, and 24.
Very good. Q's, which is 9. Can someone tell me the factor for 9? Z is from the equation here. 24 is on the last constant term, and 9 is the first term. See that? 24 and 9. Always 24 is a constant, 9 is a leading coefficient. Factor for 9, anyone? One, 3, and 9, right? Oh boy, this is gonna be fun. So can you use the rational zero test to list? This is the word. List all the possible rational zeros. So what you need to do is divide this with 1, divide this with 3, and divide the purple ones by 9. So when you divide this purple one by 1, you still get back the original one, the P's. So you get 1, 2, 3, 4, 6, 8, 12, and 24. Now I want you guys to take all these numbers and divide with 3. What do you get? It's a fraction. You got 1/3. What else?
2/3.
2/3. How about 3/3? Do we need
That's-
3? That's the same as 1, right? We don't need that. And then 4/3, we don't have 4/3. And then 6/3. Do we have 6/3?
Yes, because just 2.
So the next one is 8/3. 12/3 is the same thing as what? 4, right? And 24/3 is the same thing as 8. So this is all 3. Now you need to take all this number and divide by what? 9. I have no room here, so I'm going to copy down here. So we got 1/9, 2/9. 3/9 is the same thing as what? 1/3. 4/9. 6/9. 6/9 is the same thing as 2/3. So we do not need that. 8/9, we don't have that. 12/9. What is 12/9? It's the same thing as 4/3. And then the last one is 24/9, which is the same thing as 8/3. So these are your possible rational zeros. And again, in your homework, make sure you give me, oh, very good, Hunter. Make sure you put plus and minuses on each one of this. But in the test, in my test, you can write this. This is something I will recommend because I do not want you to do like your online homework, +1, -1, +2, -2, +2. Too much work here. Okay. All right. Since we almost get the same number here. So again, class, please. So we got this. This is what we call this list. Now the question wants us to find the rational zeros. So maybe Ariel and Hunter might reclaim from what you guys do. So again, make sure you guys write down the correct coefficient here. 9, -9, -58, 4, and 24. Yes, you guys are gonna repeat the same zeros. So Ariel, you're gonna do 1 again. For Cell, you're gonna do -1. Hunter 2, Liz 2, Nat 3, Fong -3, Sabrina 4, Sean -4, Zig 6, and I'm gonna do -6. Again, we only do till here 1, 2, 3, 4, 6 because they're all in here. So hopefully Ariel and Hunter will reclaim your error in the first place, and make sure you get your coefficient correct. Use your calculator. That's my calculator. Please give me a second. Yeah, that's lucky. So give me don't just wait for me. You guys are quick. Now this one I know is not working. And I was excited, but don't forget, in the test, it's not group work. You're gonna do it on your own. That means you're gonna do 1, -1. That's why I told you guys early on, people got make holes in my test because they've been erasing till they get holes. And again, I really strongly you guys use pencil, not use pen, because there'll be a lot of chicken scratch everywhere if you use pen. I know -6 doesn't work. I do not need to continue working it out because the number that I get here is extremely big, and the number that you try to prove here is 24, which is a very small number. So that's the reason why I know that it won't work. So 6 will not work. -6 won't work for me. Okay, let me go through with the groups here. Looks like Neda got it right. Okay. All right, let me go through the list. So Neda got it. I'm going to use pink so Neda got this one. Okay. Let me. You guys are too quick. Give me a sec. Fong say -3 not work. I'm going to put a pink sign next to it. Liz say negative not work. -2 not work. 6 does not work for me. Negatives is not working too. -4 does not work. Okay, Sean says that. Ariel, what do you mean by should work? Don't use the word should. I do not know what should. So we still wait for Fossil, Hunter, and Sabrina. 2 returns with a remainder of big negative, so that means not working. So again, we are looking for a remainder of 0. Ariel, can you should work more
I'm
harder
still
here?
struggling with the process and I'm trying to understand it. So by should work, I'm just a little bit more confused with the process. That's all. I'm trying to figure it out. Just give me time. Thank you.
Okay, I'll do 1 since Sabrina, I'm waiting for your 4. So I'll do it. 1 is the most easiest one to do compared to the rest. So drop the 9. So Ariel, what you do next? Multiply this, you get a 9. So I'm doing 1 here. So Ariel say maybe. You get 0. 1 times 0 is 0. So this is -58. 1 times -58 is -58. This is -54. Doesn't look like it's gonna be work in this case.
Got it. Thank you for showing me.
Make sure class, we did this last Wednesday, so make sure you practice this. 4 is a no. Thank you, Sabrina. Okay. Looks like 3 works since Nat was like super happy with it. So I want everyone do 3. Except for Nat, because Neta, because she did it and she was so happy. Make sure you have a calculator. So do 3. Now in the test, I won't be so cruel. I'll give you so many choices. In the test, I probably give you a little bit like this, and usually 1 or 2 will work. I just want to tell you that. Just need to double check your calculation. So everyone please do 3 since Nat says it works. This is 27. -18. And this one looks work. 3 times -18. Negative. No, negative. This is positive. Hello. So you will get 53. This is 54. So this is -4. This will give me -12. Perfect, it works. -8. This is -24. Perfect. This is 0. So it's like a Sudoku. If you guys know what Sudoku, the puzzle. So it works, it works. If it's not work, it's not work. Okay. So we try all this already. We found only 3. Now, you guys okay here? So what is going on, class, is because this is a power 4, and when you perform a syntactic, this syntactic become a power 3. A power 3 cannot use quadratic formula or factoring, So you actually have to do one more time. But here is a trick that I want to point out to you. This 3 that Netta used can be repeat. And what do you mean by repeat? It means that you can use this 3 twice. Because as you remember in 3.2, you can get a repeated zeros or a multiplicity zeros. Means that this 3 can actually work 2, 3, 4, 5 times, as because it is, you still get, that means when you write it down, it's a power 2, right? So yes, the 3 actually can, don't say, oh, I tried 3, I can demolish 3. Let's try 8, 12, and so on. No, 3 can actually work twice or 3 times, depends on, So let's try 3 again. This is another hint that I want to tell students. Although you use 3 and you found it and don't think 3 is used, so we can chuck it away, you can actually, it can be repeated multiplicity of 2. Okay? Does that work if you do another 3? Just for the heck of it. I don't think so. I don't think so. The numbers get really big here, and then you multiply by 3. So it doesn't work. So yeah, you can get, so you class, you do not need to go all the way, because once you reach to big numbers, you can stop already. That means because it's no way you can get a 0 with the big when you add with -8, right? So so that means 3 doesn't work. So don't forget, it can repeat twice. So we're gonna do with fractions now. If you want to venture, maybe 8 will work. -8. I'm gonna do I'm gonna try -8. No, forget about it. Sorry, my bad. I'm gonna go 1/9. Why I'm going 1/9? Anyone has idea why I'm picking a 9th here? Because of the 9. Okay, so when you do 9th, usually we try the 9th or maybe a 3rd. So a 9th times 9 is 1. Ooh, this one doesn't work. Then you get 19. So once you get 19, this 9 and 19, a 9th and a 19 is like, no. Okay, maybe I'm too greedy here. Maybe a 3rd. Let's write 1/3. Yeah, we can venture with fractions now. So 9. So what is a 3rd times 9? Anyone? Is a 3, right? A 3rd times 9 is 3, and when you add 18 and 3 is 21, and guess what? 1/3 goes in 21 nicely, because 21 divided by 3 is 7. So usually you can tell it works because you get a nice whole number here. You get a 3 here. Oh no, 1/3 times 3 is 1, so that does not work. Maybe negative. So this is why people get holes in the test. So 1/3 times 9 is -3. So you get 15. So that still works, because 15 divided by 3 is -5. You get a -9. Nope, this is still not working because you get 3. So the number is a little bit close. So we're gonna cross a 3rd out because that follow does not work. So this is the process of crying. Again, this question is a little bit tough. Maybe I'll do 2/3. 9. 18. 2 times 9 is 18. So 18 over 3 is 6. So 18 plus 6 is 24. Yep, have fun, right? 24 times 2 over 3 is 16. Oh, this one's possible. This will give me 12. Well, this one looks possible. 12 times 2 divided by 3. Hey, guess what? That works. So in this case, we found this 2. And so what happened is, again, when you have a power 4 functions, you have to do this twice until you reach into the quadratic here, which is power 2. So this is actually is 9x squared plus 24x plus 12. So we can factor this or use quadratic formula. So you can actually take 3 out. So you will get 3x squared plus 8x plus 4. Okay, you can factor the 3 out and factor this below. So factor this. 3x squared is 3x times x. 4 is 2 times 2. They're all pluses. So this is pluses. If you FOIL this, you will get 3x squared plus 6x plus 2x. So 6 plus 2 is 8x plus 4. So this is actually work here. Okay. And so what happens in this case that you will get your zeros here. So anyone, what is your possible rational zeros in this case? This is your answer. This will give me -2/3. This will give me -2. And don't forget, you got the 2 that you did early on. 1 is a 2/3 and 1 is a 3. So this is your rational zeros here. So looks like this, this one actually works. So class, what I can tell you right now is I think some of you still lacking of the syntactic divisions, like still doesn't have a strong sense or strong understanding about the syntactic. So this is dangerous, especially for this coming up test. So practice is something I would recommend you guys to do. Okay, and there are tons of it. You can. So if you haven't done your homework yet for the 3.2 and 3.3, I would recommend you to do so. Okay. Right, go take a 10 minutes break. We'll come back in 7:40-ish. Go do your work. Now go do your business. So Liz, maybe recheck your work.
Yeah, I'm doing it right now.
Kind of worried when you guys are 2 boo-boo and 2 mistakes here.
Yeah, I got 0. I just messed up when I was subtracting.
Be
Or
careful.
I messed up when I was adding. Yeah.
Yep. Just be careful. Just want to tell you that. Just be careful.
Yeah.
Because in the test, it's all by yourself. So, so we will continue with question 3 and question 4. So, the difference between question 1, 2, and question 3, 4 is very kind of similar. So if you look at the questions here, so they still want you to use a rational zero test, but question 1, 2, the zeros are rational zeros. But question 3, 4, they want you to find all the real zeros. So make sure you understand the difference between rationals and real zeros. Real zeros means it can be rational, means it can be, fractions, and and it can be square roots in this case. So if you got any square root in the question 1 and 2, you have to reject it. So in this case, you can have a square root answer here. So first thing first, you have to use a rational zero test in this case. So again, this is the questions they're asking us. And again, our P and Qs is based on your constant term and your leading coefficient. So what is the constant term for P's in this case? Factors. What's the factors for that?
Isn't it just 1 and 3?
Just 1 and 3. Yep, because 3 is the only one that goes in the P. And Q is the 4. Again, ignore the negative. So what goes for the Q? What factor goes for 4?
One, 2, and 4.
Yep, 1, 2, and 4. So now give me all the combinations of these rational zeros here. So when you divide this, what do you get? The plus minus. One, 3, a half, 3/2, 1/4, and 3/4. Okay. Then as usual, if you remember what I did last time is you guys have to syntactic division this till you get a remainder of 0. But sometimes in your homework or in your test, they accompany this question with a graph. So I put this function in decimals, and this is a function that I use, which is exactly the same as question 3. I put it in decimals, and it came out like this. So sometimes the good news is you can actually, if I provide you the graph, you can tell that the zeros or the x-intercept from the graph. So can someone tell me by looking at this graph, what is your x-intercept here that you can read or you can point it out exactly?
3.
3, or you can try 1. But this one on this side, you know it's negative, but you don't know what is this number is. It can be half, it can be, you know, something else. So you do not know. So so the good thing is when you accompany by graph, make sure you guys know that they give you the zeros, which is the x-intercept. So we know that 1 and 3 will work in this case. Okay, so what you do here is you just perform syntactically with one of these zeros that you found in your graph. So we can do 1. So go ahead, try 1 here. And it is -4. Don't forget the negative when you do your syntactic. 15. -8 and -3. Drop your negative. You get a -4. It should work because you know 1 or 3. I think you can do either one of this. This will give us 11. This will give us 3. This will give us 3, and this will give us 0. So this work in this case. So what we have, because this is a power 3, so we know they should have 3 zeros here. So 3 complex zeros. So again, we have the quotient. So you take this quotient and you write down in the quadratic form, because power 3, when you perform syntactic, you'll become power 2. Then you either use factoring or you use a quadratic formula to factor this. Now, if you are doing factoring in this case, I would recommend you to get rid of the negative. So you factor the negative out because if you're doing factoring, if you're doing quadratic formula, then don't need to do that. Because when you do factoring like this, I will recommend you to take out the negative. And we're going to do 4x instead of 2x and 2x. The reason why we don't want to do 2x, we use 4x is because we know 3 is one of the zeros. So we're going to do the 3 here. So we know that this will be a negative, this will be a plus. Why we know that is because this will give us 3 as your zeros. So again, you can perform foiling here. So when you foil this, you will end up with the 4x squared minus 11x minus 3. So in this case, you can take this and look at your zeros in this case. So your real zeros that you can provide to me is -1/4, +3, and don't forget the one that you guys do syntactic division early on. That is your answer in this case. So this is your real zeros. And again, class, actually this is a -1/4 here. Okay, not 1/2 or something else negative. So this is how we do question number 3 here. So the good thing about class is make sure if the graph provided to you, you use the zeros. And since another addition stuff I want to add on to the graph, and you learned this in your previous section, if your graph is crossing, it means your power is odd, means 1. So that means they only have 1 power each. What happens if your graph is a parabola? That means it's a U shape, a parabola. Then this 3 will cross twice. That means when you perform syntactic, you will do it twice, 2 3s in a row. That is something that I will tell you about it. So the graph also will tell us if you have an even or odd multiplicity here. Okay. I want you guys to try to do question number 4 here. This is question 4 in, I think you guys have my notes, right? So question 4 is this question 4. And again, I want you to use the rational zero theorem to find the to list the possible rational zero here. Okay, like what we did in the PQs here. So everyone, please do this. And I will use the decimals to do the graph of this one. So anyone can tell me what is your P's and Q's here? P's.
1, 2, 3, 6, 9, and 18.
Okay, good. That's your P's and Q's.
And 1, 2, and 4.
Yep. And class, if you just give you like this in your test, you won't get full points because for the rational zero test, you have to give me all the combinations, right? So what are the combinations? You can tell me. Don't forget the plus minus. Okay, so we have 1, 2, 3, 6, 9, 18 divided by 1. You get back the same thing. Followed by what?
One half,
1/2,
3/2,
3/2. Yep.
9/2, 1/4, 3/4,
And
and 9/4.
yep, good. Now again, because I do not want you guys to do syntactic division here because it was some of the icky fractions coming out. And so we will use a graph. So again, in the test, I will provide you a graph. A graph is not like this, it's more readable, like the decimal graph here. Okay, so can someone tell me what is the readable graph numbers here for zeros? That is a graph for the question 4.
-2.
-2. Okay, this is a really clear. This I do not know these two numbers here. Okay, so -2 is clear. That means we know for sure that -2 is a 0 in this case. So I want you guys to do syntactic division on -2. and you should work. If you didn't get 0, try again. So that work in this case. So when you perform synthetic, you should get these numbers. So now we will take this because it's a power 2 to write this in the quadratic form. So we got 4x squared minus x minus 9. Okay. And again, usually we can factor here. But if you try to factor in this case, you will notice that this quadratic is not factorable like what we did before in question 1, 2, or 3. So in order for us to find your other zeros in this case, you have to use your quadratic formula. Does anyone remember your quadratic formula?
Negative b square root b squared minus 4 times a times b all over 2 times.
Not b, for a and
Oh, and c.
b. Yep, all over by
2 times a.
2 times a. Yep. So class, again, this is important. So apply this into here. I want everyone please apply your quotient, this quadratic, into the quadratic formula to find your x. So you will get a 1 plus minus square root of b squared is 16, right? Minus 4 times negative 1 times negative 9 all over by 8. Yep. So when you multiply this, I don't think so, you get 145. Is that 145? I don't think so. It's not 145. Check your square root, Ariel. Forget. No. 4AC. My bad. You are correct. My bad, because my 4 negative 4AC. You're correct. Sorry, Ariel, you are correct. 16. Let's say 4. You are correct. 4 times 9, and then add 16. Yep, 100 and it should be 160. So 4 times 4 is 16. 16 times 9 is 144 plus 16. So this is actually 160. It's not 145. B squared. No. My bad. No. You got it right. Sometimes when I not pay attention, you are correct actually. Ariel, I'm so sorry. You are correct. I make a boo-boo here. Yep, it should be 1 squared. Yep, so it's 145. You're correct, Ariel. I am so sorry. I did the worst quadratic formula ever. So yep, everyone, yep, data, yep, thank you. Yep, you guys are right. So class, do not leave your answer like this. You have to simplify. So what you need to do here, class, is you have to simplify your 145. So you have to figure out, can we break 145 up? So it must be a perfect square. So you have to divide this by a perfect square like 4. Yep, thank you, Eureka, right? So so that is no good. 9 is also no good. So what I'm doing here, class, is I am dividing the 145 with the perfect square, like 4, 9, 16. I want to get until the number is a nice whole number, so this is no good. What's after 25 is 36. That's 6 square. No good. So 49 is the next one. So you find out that what you guys need to do here, class, is you actually have to do this until what happened is that none of the numbers goes into it. So so you can tell that I try almost every single combinations of perfect squares. So this is the end of your work. So this is considered irrational numbers because it has a square root inside. So when the question asks us for the real zero, your answer will have this with the -2. So your answer for this case will be -2. 1 minus root 145 over 8. And 1 plus root 145 over 8. So this is your answer in this case for question 4. So actually, if you look at your graph, this 0 is 1 minus root of 145 over 8, and 1 is 1 plus root 145 over 8. So this is your answer in this case. This is the real zeros, so that's why every single one of these are real zeros. Okay. So make sure you guys know this is pretty important. This is your first theorem, okay, and it's a very important theorem. It's called a rational zero test or rational zero theorem. So this is important. The next important theorem that we have is called a complex zero conjugate. So this is another important theorem. So there are 2 theorems that is important in this section. These are the 2. What is a complex zero? A complex zero occurs in conjugate pairs. So what is this theorem says that? It says that if you have a plus bi as a zero of a function, then the conjugate a minus bi is also a zero of a function. So this complex conjugate pair theorem says that if you have a complex number of a plus bi is a zero of this function, then automatically the conjugate of it will be the zero of it. Now this conjugate pairs of complex zeros function of this theorem here, it also not just work for complex number, it's also work for square root. So what does that mean here is square root of x is a 0, then negative square root of x is also a 0. So this can be proved or can be found in your your example 4. So you notice that if you know 1 minus root 145 over 8 is a 0, automatically the conjugate, which is 1 plus root 145 over 8, is going to be a 0 in this case. So the conjugate zero theorem that we mentioned here is not just work for complex, it also work for square root. Okay, so that's the reason why that when you find out this is -3 is a 0, automatically positive root 3 is a 0. So so this what we call as a conjugate pair zero theorem here can work for complex and also can work for square roots. So this is something very important. So we'll use this in finding equations. Okay, so this is will be used in question 5 and 6. So question 5 is asking us to find a polynomial function given the zeros. So we did this before in question in 3.2. So if you refer to 3.2, I give you the zeros, and I want you to give me the polynomial function. So we have to write this in a factor form. Remember, and we have to FOIL it out, right? So this is the kind of the same thing, but this one is a little bit tricky. The reason why I say it's a little bit tricky is because now it has complex, okay, complex numbers. So what happens when you have a complex numbers? You will have to use your conjugate pairs. Okay, this is something that that is important. So usually in the question, they only give you one. You have to figure out the other one. So can someone tell me what is the conjugate pair for question 5?
Would it be 4? Oh wait, what? Oh, -4 and +3.
No, watch carefully with the comma here.
Oh,
Is a 4 belongs to the 3i or not belongs to the 3i? So do not forget, this has how many zeros here? This has 2 zeros. One is 4 and one is -3i. So this is not 4 minus 3i. Okay, so this is not, this is one of the things that I see a lot of students make mistake in my test is they thought this is 4 minus 3i. This is not 4 minus 3i. This is 4 and -3i. So what is a conjugate of -3i?
would it just be 3i?
Yep, you'll be just 3i. So don't forget, conjugate pair is changing your I from negative to positive or positive to negative. So in this case, in order for us to write this, to write a polynomial functions, you have to write this in the factor form. So don't forget, factor form is written down as x minus a. Okay, so a in a 0 in this case. So can you write down the factor form in this case? So for 4, the factor form is what? X minus 4. And for -3i, the factor form is x plus 3i. And for 3i, the factor form is x minus 3i. So again, when I want you guys to write this in the factor form, your sign change from positive to negative. So that's why the 4 is negative, the -3i become positive, and 3i become negative. And you have to FOIL this question out. Now, I would recommend you to not FOIL the first 2 because one is real and one is imaginary. So I would recommend you to FOIL these 2 first. Okay, so I will recommend you to FOIL the imaginary because if you FOIL the imaginary, you will get a very clean answer or very nice answer. But if you FOIL the first 2, you will get icky numbers with i's and whole numbers and x and all these things. So I will recommend always to FOIL the imaginary part first. So leave the x minus 4 first. So go ahead and FOIL what is x plus 3 and x minus 3i. You find out that when you FOIL, you get x squared. What happens in the middle term when you FOIL this out? You guys are sleeping or what?
They cancel each other out.
They cancel each other out. So what? So you do not need to put in the middle term. So what you have in this case will be a negative 3 times 3 is 9. And then I times I is I squared. Now, make sure you know that this is a complex number. So does anyone remember what is I squared stands for?
-1.
-1, very good. So if the I squared stands for -1, can someone tell me what is -9 times -1?
It's 9.
So this is just a positive line. Okay. So what you have to do next is to drop the x minus 4 and you FOIL it one more time. So you will find x minus 4 times x squared minus I. So I want to point out to you guys is if you find the imaginary first, look what happens is your eyes is gone. Okay. So this is something that I would recommend you guys to do. Make sure you find the imaginary first before you find it with the nice number. Like, so go ahead and find this one out, and that will be your answer. And don't forget to put f of x since the question is asking for a polynomial function. So make sure you put f of x in front of it. Okay, I'll leave this to you. So I think you guys know how to find this. Go for it out. Okay. So same thing with question 6. I want you guys to give me another zeros that is not given to us. So this question gives us 2 zeros, number 5, and 3 minus 2i. So can someone tell me what is the other zero is? That sometimes I don't like Zoom because I don't know what you guys doing there.
Would it be 3 plus 2i?
Very good. Okay, so don't forget, this is called the conjugate pairs. Okay, so now we're gonna write this in a factor form. So how do you write this in a factor form? So for 5, it's not too difficult to write because change it become x minus 5. Does anyone know how to write 3 minus 2i in a factor form?
Would it be wait, does it have an x in it?
Yes, factor form always have x in front. Yep.
Oh, would it be x plus 3 plus 2i?
Don't forget, in order for you to write the factor form, all your sign has to be switched. So it should be x.
Minus 3 plus 2i?
And how about the last zeros over here? X minus 3 minus 2i. So again, when you guys write this in the factor form, make sure that every single one of these will switch your sign from positive to negative and the other way around. And again, class, where do you need to foil first? Are you foiling the first 2 or the last 2?
Last 2.
Last 2. I just want to point out to you, if you foil the first 2, have fun with it. You will have a nightmare going on. Okay, so foil the last 2. And this is a 3 terms. This is a 3 terms. So when you foil this, you should get 9 terms. Okay. So when you foil this one out, you get 9 terms. Go ahead and foil it out. And some of the terms, once you get the 9 terms, some of the terms can be canceled. Class, this is something you guys need to do. This is in your test also. You get when you foil this. You get x squared. So you take x, multiply everything back here. So it will be minus 3x minus 2ix or 2xi, doesn't matter. And then you take the negative 3 and you multiply it to all those factors. What do you get? Negative 3x plus 9. Negative times negative is positive 6i. And lastly, you take 2i and do the same thing to the rest of this. And that's where you get your 9 terms. So this will give me 2ix positive. 2i times 3 is negative 6i. And 2i times negative 2i is negative 4i squared. So what can you tell me here when you void this? There are nine terms here. Something can be canceled, right? So what can we cancel?
2ix and negative 2ix.
What else? The 6i will be canceled. And do we know I square again?
It's -1.
-1. Do you see any more I left over in this case? You did not see them, right? All the i's either cancel out or become -1. So this is how you know you are doing it in the right way is when you do the conjugates of your i's here, when you FOIL it out, you will not have any more I or I squared terms. So when you get this is a clean function or clean polynomial function here, a quadratic function actually. So you don't see any I. So if you have any I left over here, something is wrong with your factoring. Okay. So what you get here when you combine them all up, combine like terms. So it's x squared minus 6x. And this 9 is what? Added or subtracted with 4?
Wouldn't it be 9 plus 4?
Yep, because these two negative become +4. So what's 9 plus 4? Become 13.
13.
And this is, see that? This, when you FOIL it, is very nice. No I term. Again, if you see any I terms, we do it again. But don't forget, we still have x minus 5 in the middle, in the beginning. So you have to do what again? FOIL it out one more time. So there's a lot of foiling in this part 2, this question, where you have to FOIL this one up. And then don't forget to give f of x up. So go home, do this. I know you know how to FOIL it, so make sure you guys FOIL this and then combine like terms. And whatever you get here, if you did it correctly, that will be your answer in this case. Okay. So this is main part of this kind of questions. I think we did it before in 3.2. The only thing that you need to watch out here is the complex conjugate, means that they only provide you 2. Actually, there are 3. Okay, or they give you 3. Actually, there are 4. Okay, and the conjugate is the 4th one. Okay, the conjugate pair. The next one that we're going to talk about here is number 8. So question number 8 in this case is where they provide you the 0 and they want you to find all the zeros in this case. So when I say find all the zeros, it means that your zeros can be real and can be I. Okay, so that means the zeros can be anything we want. This is a power 4 and they give us a 0 is 5i. So can someone tell me another 0 here?
Would it just be -5i?
Yep, the conjugate. Okay, the conjugate pair. So this is again very, very important class. In a test, usually again, I provide you one, the other one, make sure you know how to do it. Again, in order for us to prove that this is a 0 of this function, you have to perform syntactic division. I say, oh my God, David, you have not taught us how to do syntactic divisions on I. remember we only did nice number 1, 2, 3, 4, 5. We do fractions, right? 1/2 and stuff like that. We didn't do anything with the I form. So can we have a syntactic divisions with an I form? The answer is yes. It's the same type of syntactic division. So coefficients for the inside here, 2, -1. I'm going to write this a little bit spread out because it is going to be a little bit I will recommend spread out in this case. You need a bit more space to write on. Again, watch for your sign, the negatives. So we're gonna start with 5i first because we know 5i is a 0, and then after that we do the -5i. So as usual, when you perform syntactic division, we will drop the 2. And then when you multiply this, so 2 times 5i is 10i. We add these 2 up. Don't forget, we always add. Unfortunately, you cannot add this up because one is imaginary, one is real. So it becomes -1 plus 10i. Okay. And then you have to take the 5i multiply to this. So this is kind of like work in this case. So you have to take 5i multiply by -1 plus 10i. So you have to kind of do a little bit distributive here. So this times 5i times -1 is -5i. This times that, 5 times 10 is 50. And you got I squared, and we know I squared is the same as -1. So this will give me -50 minus 5i. So that's the reason I want you guys to put a bit more room here because you have to, a bit more stuff to do here. So class, make sure you just treat it as the distributing that you guys learned last time, and then change your I squared become -1. When you add this one, now these two, the 49 and 50 can be -50 can be added because they are numbers. So you will get a -1 minus 5i. And you have to do this, you have to distribute 5i again to this. So we got 5i times with -1 minus 5i. So kind of a repeat. So this times this is -5i. This times this is -25i squared. And since I squared is a -1, so this will become a 25 minus 5i. And the good news is when you add these two up, the 25 and -25 will cancel out. So you get -5i, and then you do the last thing here. So 5 times -5 is -25. I times I will give us I squared. But as you know that I squared is a -1. So that will change him to become positive. So negative become positive. And when you add this, you get a remainder of 0. So this is what, yes, your syntactic division can perform not just nice number like 2, 3 negative fractions or negative. You can perform with complex 2, like 5i in this case. So we're going to do it one more time with -5i because of the conjugate pairs we have here. So you will find out when you do this second time, it's like our polynomial here. You find out that your i's will be all cancel out. It means your quotient that you get here is nice whole numbers. Okay. So multiply this, you get 10i. And this is what happens when you add this up. The 10i will cancel out, you get -1. So this is usually what you will get. And if this does not cancel out, something is wrong with the first syntactic division. Okay, usually there is a cancellation out. And then when you multiply the next one, you also get a negative times negative is positive 5i. And what do you notice is your 5i will be canceled out to become -1. So these are the few tricks I want to point out to you when you guys do the i's, when you do the conjugate pairs here, is your i's will cancel out. And then this is definitely give me a positive 5i. And that also will cancel out, become 0. So you notice that your quotient that you get when you perform it the second time using your conjugate pair is I-free. That means it doesn't have any I. If you have any I left over here, check again with the first syntactic, means you did something wrong. So these are all the hints I always tell my students. So you can stop when you have any, like here, the same thing here. If you have any I, stop, check. Okay. So we got this in a quadratic form. So you can either use the quadratic formula to solve for your rest of your zeros here, or you can factor it. So again, class, it's up to you. Factoring is not all polynomials quadratic can be factored. If you are good in factoring, you should tell very strictly this one can or this one cannot be. A lot of practice. Otherwise, quadratic formula is a universal formula, means any quadratic equations will work, so it doesn't matter. This one will be, the factoring will be, this will be 2x plus 1 and x minus 1 for this case. So the question here is asking us for all zeros, not real zeros. So the all zeros in this case will give us this number, which is -1/2. This will give me +1. Okay. And don't forget your i's or your 5 i's that you guys did syntactically. So this will be also your zeros in this case. So you will have 4 zeros. Both of them are real. These are the reals or rational. And the other 2 is imaginary, the 5 i's. Okay. So as you know, this is a power 4 equation. So degree. So you should have 4 zeros in this case. So this is how we figure out your zeros in this case, and make sure you know how to do a little bit of syntactic division with your i's. So questions, anyone?
Yeah, how do you know when you have to do your synthetic division again?
The question is given as zeros. So if they give you multiples, then you do it multiples.
Okay, okay, cool.
Yeah, but this one only give you 1, so we know the other one by doing the conjugate. Okay, so so usually if they give you 2, if they provide you zeros, mostly everything we did here is syntactic division, right? Except for this question, when they provide you zeros and they want you to find a polynomial, then we don't do syntactic. But the rest of this, we've been doing syntactic since the beginning of the class, right? Question 9 and 10 is a repeat of what we did in the beginning of the class, the 1 and 2, question 1, 2, 3, 4. But this time they want you to list all the zeros. That means last time, if you remember what we did on the question 1 and 2, they wanted rational. This one they want real, and this time they want all zeros. Means all means including rationals, irrationals, I, complex, everything goes in there. So in order for us to do this kind of questions, again, because they don't provide us zero, so you can do syntactic, then it's a needle in a haystack. You don't know what to do with which one to syntactic with. So I would recommend using PQs here. Okay. So again, class, if a question provide us zeros, syntactically, you do not need to do PQs, okay? But if a question did not provide us any zeros that you see here, any zeros, then you have to do the rational zero test, the PQs. Same thing with question 9 here, 9 and 10. They did not provide us any zeros here, so you have to use PQs here to figure out your syntactic. So this is actually easy, question 9. Make sure you guys know when do we use PQs and when we don't need to use PQs. Anyone PQs on number 9? It's easy actually. This is something you get in my test, easy. Or the 9 and 10, these two are not too difficult. Anyone PQs?
2 and 1.
So this is your P, so it means it's 1 and 2 or 2 and 1. And what is Q here?
1.
1. So the only thing goes in 1. So what is the PQs in this case? Plus and minus what?
1 and 2.
1 and 2. So this is very, so that's why I say this is coming up in your test, because you do not need to do a lot of synthetic division here. So I'll drop down the coefficient. So 1, -3, 4, and -2. Anyone feel lucky today? 9 will not work, Hunter, because 9 is not a part of this. I don't think so 9 will work here. Oh, sorry, I didn't read that. So 1 and 2. So Hunter say, so anyone feel lucky? Again, that's where I will try 1 first. So drop the 1. 1 times 1 is 1. You got -2. 1 times -2 is -2. Oh, this is actually work. 4 minus 2 is 2. So 1 times 2 is 2. This is 0. Oh, this is actually perfect. Good job. Sorry about that. I didn't read through, Hunter. So this is your so sometimes if you are lucky like this, 1 shot, you do not need to perform as many. And I can tell you usually it's either 1 or 2. That's, you know, that is the number that you should come up with your test. So I won't give you crazy like 9 or 15 or something else like that. Okay. So we have this. So that's your quotient. So you become x squared minus 2x plus 2. Anyone knows, can we factor this fellow? Can we factor x squared minus 2x plus 2? No, we cannot factor this. So if you cannot factor this, then we will use the quadratic formula. So I want you guys to go ahead, apply the quadratic formula for this quotient. And if you know how to do this kind of work, I am really happy, because your test 1 will be mostly like this. Where you have to, I mean, for this chapter 3.3 and 3.4. Anyone, quadratic formula? Error. Because of the imaginary, that's why. I just want to point out to you guys that do not use your calculator when you get a negative inside the square root, because your calculator will tells you error. So make sure you guys know that when you see when you guys see a negative square root, let's say -√9, make sure you yank the negative out, become I. Okay, and this will become a 3. Okay. So don't forget, this is very important. Do not put root of -9, then you get an error message in your calculator. So yes, this time is a negative. So negative b is 2. Plus minus b squared is 4. Minus 4 times a is 1 and c is 2, all over by 2a. So 2a is 2. Okay. And what you get inside this square root here?
Is it -4?
-4. Now, this is something that I see a lot of students do in my test. So please pay attention and do not do this, because if you do this, it's wrong. Oh, look, we got 2 and 2. We can cancel this 2 and 2. Okay, class, this is the most biggest, and then this one will give me 2i, plus and minus 2i. So my answer in this case is plus and minus 2i here, because 4 is a perfect square of 2, right? What I'm doing here is the purple one that I write is completely wrong. You will get like a point deduction here in your test. It's because you cannot do this due to when you have a plus and minuses in the middle here, you cannot cancel your 2 like this. Okay, so what you need to do here is separate these 2 up. This is something very important. You also will use this kind of a little cheat thing here to separate this when you go to your trigonometry class. So so we know that root of -4 is 2i, right? Because root of -1 is i. And you will separate this into double 2 like this. So this is what I strongly suggest you to do. Don't do the one that I just showed to you. So 2 over 2 is 1, and 2i over 2 is i. Okay, so what will be your all zeros in this case? So your all zero in this case will be 1 plus minus I. There are 2 answers here. One is plus, one is positive, one is negative I. And don't forget the one that you guys did syntactic division, because this is a power 3 functions, polynomial functions. So you should have 3 answers. And again, I mentioned a lot in your online homework. Please write this as 3 separate answers. Don't use the plus minus here. Okay. So this is how we do these questions. And yes, these kind of questions will be in your test 1. Okay, like 9 and 10. All right, repeat. Now this is even difficult than number 9 because it is a power 4. Okay, so when you have a power 4, you should have 4 zeros here, not 3 but 4. So when you have a power 4, you have to perform syntactic division twice, because power 4, when you do it one time, become power 3. You do it another time, you become power 2. And once you reach power 2, you can use your formulas, your quadratic formulas or factoring. So that is our goal in this chapter 3-4 here, is we reduce your quadratic into a power 2 so we can factor it or use quadratic formulas. So in order for you to have a power 4, you have to do syntactic division twice. I don't give you 5, 6, and 7, because if I give you power 7 or power 6, your work is going to be 2 to 3 pages long. And you do not like, I would not like to grade it. You do not like to do it. And it's horrible. So usually in the test, either it's a power 3 or a power 4. If it's a power 4, then you have to be careful because you need to do syntactic twice here. Okay. All right, first thing first, PQs. Because this question did not provide us any zeros at all. Okay. And if I will tell you, if they provide zeros, your life is a bit easier. Otherwise, your life depends on PQs. Anyone? P's, Q's? I do Q. Q is 1. That's easy one. And what is P? Anyone? Factor for 16?
Yeah, 1, 2, 4, 8, and 16.
And what is PQs in this case? Don't forget the plus minus. Same thing, right? 1, 2, 4, 8, and 16. We'll get the plus minus. So we're gonna do syntactic division here. And again, these are your coefficient. 1, -4, 8. Don't forget, class, in the test, it can be a missing X term. Remember on Wednesday, I told you, if you have a missing X terms, you have to put a 0 on it. So far in this section, you couldn't see anything yet. In your test 1, you will see some of them is missing a cube or missing a X term. So you have to insert a 0 for the placeholder. Anyone feel lucky today?
Oh my God, I
Two.
didn't even realize there's this.
Oh, 2. Oh, okay, good. So we're gonna try. Okay, everyone try 2 now. So good. Nat try 2. Then I try 2. Yep. So 2 times 1 is 2. So you got -4. 8. You got -8. And you got -16. This is 0. Good. 2 works. Okay. Yes, I already told you, class, right? It's either 1 or 2. Either number 1 or number 2, or -1 or -2. That's it. In the test, I wouldn't give you more than that. Unfortunately, class, that this fellow you have to do syntactic again is because this is a power 4. So when you perform syntactic, it's power 3. So when you reach power 3, we cannot do factoring. I mean, if you can someone factor this? Can someone tell me what is the quotient here? If you can factor this, that's good news. X cubed minus 2x squared plus 4x minus 8. Does anyone know how to factor this fellow? If you say yes, good for you. If you say no, syntactic division. Anyone know how to factor that fellow? Oh, yes, groupings. Yes, you can try groupings. Yep, cut this. Grouping means cut this into 2. What can we factor out for this 2? X squared. So you get x minus 2. Now, don't forget, when you do groupings, the x minus 2 also has to be on this side. So what can we factor out on this 2? A 4. And what you get? Also x minus 2. So class, every time when you do a factor of grouping, this 2 has to be the same. If they are not the same, that means you have to do syntactic again. So that means x minus 2 is one of your factor, and the leftover in this case will be x squared plus 4. And now we will have to solve this. You have to make this all equals to 0. So this will give us 2, because this is nicely. Anyone know how to do this case? So this will be x squared plus 4 equals to 0. I move the 4 over, so become x squared equals to -4. And I take the square root. So class, this is something that I still see students forget. What do you guys need to have when you put a square, when you use a square root property on this case? You need to have a...
You have the plus or minus in front of it.
Yes, the plus and minus symbol. So this is the most common mistakes I see students make in my test is forget. And yes, then the 2i, don't forget. Yep. So the plus minus is important. So that means how many answers you have here? Just the orange writing here. You get 2 of them. Okay. So now let's, the 4 is 2 and then the negative is I. So what is your all zeros in this case? Anyone? So it will be 2, Now the 2 is already here, so you do not need to have another 2 because it's a duplicate, and then plus minus 2i. Okay. Now another way is, yes, if you syntactic division here with another 2, and you will end up with a 0. So this is telling us that this follow has a multiplicity of 2 as x minus 2. Okay, so if I want you to write this in a factor form, okay, the g of x here, as you know that factor form, you got the zeros, you can change it to, so this will become x minus 2. And then this will become x plus 2i. And then x minus 2i. And because of the 2 came up twice, one here, one here, so this x minus 2 has to be square. Okay, so this is what is in the factor form in this case, is you just, like what we did last time, just change your sign. But the only thing I want to point out here is this x minus 2 here has to be square, is because it has a multiplicity of 2. Now, or even. Do you guys still remember what happens in the graph if you have a multiplicity that is even? Anyone remember that in 3.2? It actually what? Tangent, right? Not cross, right? So when you draw this graph in your decimals, okay, this is something that also you guys, so it's x to the power of 4 minus 4x to the power of 3 plus 8x squared minus 16x plus 16. So what do you notice in the decimals graph when I type this is the 2, which we know from the performing syntactic here, that is actually given us a multiplicity of 2 because it is a touch. So that means when you perform syntactic division, you're going to perform it not once, but twice. But wait a second, so the 2 shows here, but why the 2i does not shows in here? The reason why is because this graph is only graphing the real graph or real zeros. So any imaginary zeros that you found is not shown on the graph, okay? Because this graph is only real graph. That means it's for real numbers. So all the I that you guys get here in your answer, it won't shown in your graph, the real graph. Same thing happens in question 9. This graph will cross at 1. This it won't show because it's an imaginary. Okay. So again, class, make sure you guys know this. This is something that is important to tie the whole chapter 3 up together. So multiplicity that we talk about, imaginaries, and so this is the end for 3.4. We do not know. So who was this? Neda asked me, how do we know? We do not know until the graph shows us. So if there is a graph given to us, then we know that this one has a multiplicity is 2. Okay, but if the graph did not give it to us, we don't have this graph, then you have to try it again. Remember on the first time, yeah, the graph is usually if I want a multiplicity of 2 like this, usually I will give you the graph like that. Okay, so if I want a multiplicity of 2, I will give you the graph. Okay, so I won't be mean that so I will give you this graph. So you have to know that this graph shows us this 2 is twice. So when you do syntactic, you have to do it twice in this case. Okay, usually I will provide you the graph. Okay. All right, so that is the end for today's class. So you do have 3.4. The rest of it, you do not need to worry about the Descartes rule of sign, the upper and lower bound. We don't concentrate much on those. Mostly in your test is the watching for the multiplicity of 2, doing PQs, and doing synthetic division. That is the most part that I will tell you here. Again, question 14 here is about the same thing we do early on about the open box. Okay. So I will give you a notes for this 3.4 here, which is have the Descartes rule of sign and the open box here. So when you do your homework, you can refer to it. This homework is due not on Wednesday, it's due on Tuesday next week, not this coming Tuesday, which is the 8th. So this and then when you come to class on Wednesday, you get chapter 4 notes. So if you don't have, very similar to it. And no, open box will not be on your test because it's a lot of work. Okay, so this won't be in your test. So so again, class, to come to class on Wednesday to get your chapter 4 notes. If you did not come to class on Thursday, then go to D2L and print out your chapter 4 notes in this case, right? They're all, again, class, go under material and content. You will get under the notes, you will get the chapter 4 notes. And again, class, the instructor notes that I have here is the full written notes. So actually you can get it from here. So remember the question open box and everything that I skipped or I did not do, please refer to this instructor notes here. So make sure you guys, this is the open box that we talk about. So I would recommend if you guys any empty place, please go to the instructor notes and get my notes, which is very similar to what we did in class. So that would be something that I would suggest you guys to do. Okay. So any questions